Okay, so this is section 5.5, number 55, and this one's just a little bit tricky, so I just thought I would go ahead and do a little video. So the first thing I did, well, we're supposed to solve for x on the interval 0 to 2 pi. And so the first thing I did was I used the quotient identities, and I changed tangent 2x to sine 2x over cosine 2x. And I changed secant to 1 over cosine 2x. And then I multiplied that equation through by cosine 2x to get rid of the fractions. So we end up with sine 2x plus cosine 2x is equal to 1. And then I used the double angle identities. So sine 2x is 2 sine x cosine x. And then cosine 2x is cosine squared x minus sine squared x, and that equals 1. And then I thought about the Pythagorean identities, that if I move this cosine squared x over to the right side, I'll have sine squared x over there. So just rewriting that, and this would be just minus sine squared x. And then I move that cosine squared x over here, and then you can see that this right side is equal to sine squared x, because that's what that Pythagorean identity tells us. So if I move that back to the left side now as sine squared x, I'm going to have minus 2 sine squared x over here and 0 on the right, which is what I want to do because I want to be able to factor the left side and have the right side equal to 0 so I can use the zero factor theorem to solve it. So I'm going to factor out 2 sine x, and I'll have cosine x minus sine x right there, and that'll be 0. Now I've got it factored, and so I can set each of those factors equal to 0. If 2 sine x times the quantity cosine x minus sine x is equal to 0, that means one of them has to be 0. So 2 sine x could be 0, or cosine x minus sine x can be 0. If 2 sine x is, 0, then sine x is 0, and therefore x would be 0 or pi. Those are the places where sine is 0. If cosine x minus sine x is 0, that means that cosine x equals sine x. And that happens in the first and third quadrants where we have pi over 4, because that's where you get square root of 2 over 2 for both of those values. So x would be pi over 4, or could be 5 pi over 4. So pi over 4 and 5 pi over 4 cannot be solutions, because when you put pi over 4 into the original equation, for example, you get pi over 2 here. Secant pi over 2 is undefined. Tangent pi over 2 is undefined. Same thing. If you put in 5 pi over 4, that's 5 pi over 2, which also gives you an undefined value for secant and tangent. So these two values cannot be solutions. So the only values that actually work in the original equation would be 0 and pi.